So now we will find out the inverse of a 3 by 3 matrix. For doing this, you know how can we find out the inverse? Inverse of A is given by adjoint of A divided by determinant of A. Now for finding the inverse of any matrix, the first step is to find out the determinant. The inverse exists for any matrix when the determinant is not equals to 0. So first thing, you have to check whether it is the determinant is 0 or not. So here determinant of A is equals to, we can expand it along the first row. So you will get, so here you can see the determinant of A is coming -3. Now you can say that A is non-singular matrix, so therefore your A inverse exists. So this step you have to write in every question, that the determinant is not equals to 0, that means the A is non-singular. So A inverse exists, and A inverse is equals to adjoint of A divided by determinant of A. Now we will find out the adjoint of A. So for doing finding the adjoint of A, we have to find out the cofactors. So first we will find out the cofactors. So here C11 will be how much? This I have told you earlier also. For finding the C11, what we have to do is C11 is the determinant of the A11. Now for finding C11, C11 is the cofactor of A11. So A11, you can see this is your A11. So you don't have to write this one. Remove this row and remove this column. So see what you will get. So here we have only -1, 0, 2 and 1. Okay. Now one more thing you have to write, that is -1 to the power. It is 1, 1. So you have to write here 1 plus 1. So your C11 will come. This one will be positive. So C11 will be -1. The same way you can find out C12 also. So C12 will be -1 to the power 1 plus 2. And then for C12 you have to remove. Now while finding the C12, C12 is the cofactor of A12. So this is your A12. So you have to remove this row and this column. So see, after removing this, what you will get? You will get this 4, 4, -7 and 1, 0, 1. So that I have written here. So whatever the cofactor. Now for C13, you can see you can remove the first row and the third column. So the remaining elements are 1, -7, -1 and 2. So after solving this, you will get h minus 7, that is 1. So like this you can find out the cofactors of first row. Now we will find out the cofactors of the second row. Now for C21 it will be -1 to the power 2 plus 1. So here the power is odd, so you will get negative. Now you will solve this one. What we have done here, the second row you can remove and the first column. So you will get 1, 2, 3 and 1. So that I have written here. So now it will be 1 minus 6. So you will get -5. So it will be +5. Now you can find out C22. So for C22, again what you will write, -1 to the power 2 plus 2. So it is positive. So after that, for C22, second row and second column. So what we will get? 2 minus 7 and here 3, 1. So after solving this, you will get here it will be positive, -1 to the power even, so it is positive. So here you will get 2 plus 21, so that will be 23. So the same way you can find out C23 also, -1 to the power 2 plus 3, and then second row, remove the second row and the third column. So you will get 2 minus 7, here we will get 1, 2. So after solving, here it will be negative because -1 to the power odd, it's minus, and then here we will solve it. So you will get 4 minus of minus 7, so it will be +7. So it will be, I'll write it, 4 plus 7, so it is 11, so -11. So this we got. Now we'll find out cofactors for the third row. Now we'll find out C31. So 3 plus 1 is even, so here positive sign will come. So your cofactor will be, here we will remove the third row and the first column. So what we will get? 1, 3 and -1, 0. So it will be 1, 3, -1 and 0. So after solving this, you will get 0 minus of -3. So answer will be 3. Okay, so we got this one, C31. The same way you can find out C32. So 3 3 2 will be, see, sum of these two is odd, so you'll get. Now the adjoint of A is transpose of the cofactors of these. So you can simply write, this one is transpose, I think you know that one. So transpose of this, you can also write it as, all the row will become column. So it is C11, C12, C13, C21, C22, C23 and C31, C32 and C33. So you can simply write this adjoint of A is this, okay, or transpose of this. Now you can write the adjoint of A. So our C11 is -1, C12 is -4 and C13 is 1. The same way C21 is 5, then C22 23, C23 -11, here we got 3, and this one is 12 and this one is -6. So this way you can find out the adjoint of A. So this is your adjoint of A. Now we have to find out the A inverse. Now these things we have found already. The determinant of A in the first step we have already found, that is -3, and adjoint of A also, now we have calculated that one also. Now you know, when determinant of A is not equals to 0, then A inverse is given by adjoint of A divided by determinant of A. So here we have all the values, so you can write it. So here it can be written as 1 by A into 1 by determinant of A into this matrix, that is -1 5 3 -4 27 12 1 -11 -6. So this is that one, and here in the place of A determinant of A you can put the value. So here your A inverse is this. So I hope all of you are getting. So the first step is to find out the determinant of A. So A inverse exists if the determinant is not equals to 0 or A is non-singular, and after that you have to find out the adjoint of A. For finding the adjoint, first you have to find out the cofactors, then you have to take the transpose of the cofactors of A, of matrix A, and afterward A inverse is given by adjoint of A divided by the determinant of A. So like this you can find out the A inverse.